Okay, so this is just a quick review video about our conversations on arithmetic sequences and sequences in general. So first was, what our goal is here is to be able to offer a definition of what arithmetic sequences are, and then to represent arithmetic sequences using words, tables, graphs, and equations. In the next video, we'll look at some applications of arithmetic sequences to problems of population growth and simple interest, using both Excel and Python to solve these application problems. So first is a reminder about the definition of a sequence in an arithmetic sequence. Arithmetic sequences are recognizable by a constant change in terms, a constant change by a constant addition or subtraction between every term. So in words, what this would look like is maybe start with 2 and add 3 every time. So here is an arithmetic sequence expressed one way in words. In symbols, we represented this recursively by saying that the next term is equal to the previous term plus 3, and we're saying our first term is equal to 2. And this was our recursive definition. From here, if we wanted to build a table, our table would contain both the term number and the term value. So for example, in this sequence we start at 2 and we add 3, so that would be 5, sorry. We add another 3, we add another 3, and so on and so on, and we get a table of values here. We can also represent this table of values symbolically using function or a closed form definition, where I want to know, given any n value, what the value of the term would be. We noticed that this constant addition of 3 means that however many terms we have, we will have added a multiple of 3 to the beginning term. So to start, we're going to add no 3's. So when n is 0, we'll have 2 plus 3 times 0. When n is 1, we'll have 2 times 3, 2 plus 3 times 1, which is 5. When it's 2, we have 6, 2 plus 6, 8, and so on and so on. So we have a different representation in closed form. And finally, if we wanted to rewrite this using function notation, we could write this sequence as having input n, and it's equal to 2 plus 3n. Notice the difference, it's just that we're using function notation here. Finally, a graph of our sequence. Along this axis we have the term number, and here we have the value. So at 1, this is 5. At 2, it's 8, and so on. And we should see this kind of pattern of a straight line forming. This was another key characteristic of arithmetic sequences.